Okay, now, some of the downsides of VSDs. We've got very, very high frequency stuff occurring. Very high frequency stuff. And it's like waves in an ocean. The bigger the ocean, when you have waves in an ocean, they're always bouncing off things like islands and ships and whales and stuff like that. And when two waves meet, they could just pass through each other, or they could join together and cancel out, or they could join together and add to each other. Now, if you have a very big ocean, there's more chance that 200 waves will all meet in just the right way so they all add up together. And that causes a thing called a king wave. When you have very big oceans, you get these king waves, which are very rare phenomena, but they're massive waves, where 200 waves just happen to have met in the right place, so they all added together. Now, king waves have been responsible for a lot of damage. A king wave hit the QE2 and blew out the windows on the observation deck. A king wave hit a Second World War destroyer just near Albany and actually turned it entirely over, capsized it and then turned it back. And we're talking a Second World War destroyer, which was a big, heavy chunk. So the bigger the ocean, the more chance there is of these king waves. The same sort of thing happens with waveforms in copper. The more copper you make available to it, the longer the cable, the more likely it is you're going to create spurious waves, spikes. Now, this is a picture of, here is a picture of the waveform leaving the VSD. This is the voltage waveform leaving the VSD. And of course, that averages out to a sine wave like this. Okay. With excessive cable length, this is a picture of the voltage waveform arriving at the motor. As you can see, you've got spikes on it. These spikes can be 1200 volts high. Here's a blown up diagram of one. This is one part of a waveform, and here you've got a big spike arriving. Now, this is what occurs if you give it too much copper. Basically, if you make the cable too long. And by making the cable too long, this may surprise you, what I'm talking about is greater than 30 meters. If you make the cable longer than 30 meters, you're going to start generating spikes. Now, possibly some of you have seen VSDs installed with cable runs longer than 30 meters. Would that be correct? Now, this is something, now I'm going to talk about, this is speculation. This is my own personal theory. There is one thing that VSDs are famous for, and that is shutting down for no apparent reason. Every now and then, with almost all VSDs, every now and then, for no apparent reason, on a wet Thursday, the VSD trips out on earth fault, or overload, or imbalance, or some silly reason. Sometimes it's a different fault each time. Sometimes, every single time, it's earth fault. All you do is you go up to it, you press the reset button, and it up and runs for another 6 months. Now, has anybody seen this type of thing? Just a weird, very, very intermittent fault that you can't really tell what's causing it. Okay, this is my theory of what's causing this. My theory is that you've got 3 lugs in the terminal box, and you've lugged your cable onto them. And normally everything's sweet. But every now and then, every 18 months on a wet Thursday, one of these nasty king wave spikes comes along, and it's a 1200 volt spike. And that 1200 volt spike is enough to go tick, just down to earth. Now, this has lasted for, what, a 10,000th of a second. You're not going to notice it. It's the tiniest of little ticks. Just a quick tick, 1200 volt, one tiny part of one of these spikes down to earth. You would never ever see it. However, the VSD does see it. The VSD detects that. And the VSD immediately shuts down earth fault. And you think, well, that's very strange. You come along and you press the reset button and the VSD starts back up. If it gets to be a nuisance, of course, you call the manufacturer, and the manufacturer comes out and he changes the control board. 18 months later, it does it again. So he comes out and he changes the big power board. 18 months later, it does it again. So he comes out and changes the entire VSD. Does it again. So you think, okay, it's the motor. So you change the motor, still does it. You change the cables, still does it. Now what you've got is you've got a broom. You've changed the handle and you've changed all the bristles, and it still won't sweep the floor. So really, something else is fundamentally wrong here. And I reckon, this is my theory and I've got no proof of it, I reckon the problem is that we're running long cables. We're running cables too long. We're giving it too much copper, and every now and then, every 18 months on a wet Thursday, a spike comes along, just goes tick down to earth, and the VSD shuts down with an earth fault. Okay, so that's one problem. Another problem is that VSDs work in the radio frequencies. When we're creating our waveform, we're not... Oh yeah, the copper in the windings are really long, but there's not much of them physically. Now, problems with lengths. The problem with length of cable from the I need a black pen. From the VSD to my motor. My 3 cables going that way. My problem is that the VSD is not outputting 50 hertz. It's actually creating hertz by outputting 10 kilohertz, which is in the radio frequency. Now, if we put in normal cables, then when you put radio frequency onto a long length of copper, we've got a name for that. When you put radio frequency onto a long length of copper, 30 meters, we call it an antenna. That's how we make radios. I mean, that's how we broadcast. If you put a VSD on unscreened cable, it will transmit at 10 kilohertz. It will transmit radio VSD. And radio VSD is very, very destructive. Radio VSD will travel a long way. Basically, if you're talking about 10 kilohertz on a 30-meter cable, well, that's pretty well what the ABC radio use in the Perth metro area. So you're transmitting that kind of radio signal power. You will completely and utterly disrupt any communications. You will totally destroy anything like field bus, Profibus, or Ethernet communications will shut down. Now, they won't always shut down. It may be that when we run at 47 hertz, all of the field bus shuts down. It may be that when we run at 46 hertz, all the temperature sensors stop reading. It may be at 43 hertz, all the pressure sensors stop reading. You get these funny things where things will stop communicating. In addition to that, any piece of metalwork alongside, so if I have a metal framework or a ladder work or even any piece of metalwork alongside these 3 cables will have voltage induced into them. And I have heard reports of people touching metalwork, which is alongside VSD cables, and getting a boot off of the metalwork. And we all know that tingly boot feeling. People have got electric shocks off the metalwork. If you use unscreened cable, people have got electric shocks. So there's that problem also. In addition to that, if you use unscreened cable on a large VSD, you are probably contravening the regulations on, this is what's called non-ionizing radiation. There are rules about how much radio frequency you are allowed to absorb in your body. Non-ionizing radiation is radiation. It will cause cancer. If you use unscreened cables, you are transmitting high levels of non-ionizing radiation. You're probably breaking the rules on that. So we should always use screened cables. Whether or not we use screened cables, there are still minimum distances that we have to maintain between our cables. If we're running a cable run of less than 30 meters, we need to maintain a cable separation of greater than 10 centimeters. Greater than 30 meters, we basically have to have one set of VSD cables on a ladder all by itself. And what I'm talking about with this separation is that cross-section wise, if that's your trunking, you've got your 3 singles going out to one VSD. Another VSD, its singles must be separated, if it's longer than a 30-meter run, by 25 centimeters. If you don't, then what happens is they cross-couple to each other, they induce currents in each other, and effectively they donate copper to each other. So you get even worse spikes than you would have done anyway. So you'll be getting even more of these strange intermittent faults. You certainly should not have any comms cable or any other type of cable within 25 centimeters of any of these VSD cables, because they're just going to induce, screened or unscreened, still got to be 25 centimeters. Even screened cables will still generate a certain inductance. Well, if you've got cables from the same VSDs, there should be 3 singles together, and as far as I know, it's quite all right to bundle those 3 together. But if you've got cables from singles from another VSD, you separate them away. If it's less than a 10-meter run, you can separate them by 10 centimeters. But if it's greater than that, you've got to have a 25 centimeter separation. Running 13 motors off one VSD, I would say that if you have one VSD and 13 motors, that basically we're talking about the total amount of copper in that run. So being as the chances are that the total length of copper is greater than 30 meters, I would say that they all should be separated by 25 centimeters. Because otherwise, what we're going to have here is an awful lot of copper available to generate lots and lots of nasty spikes. Because if you just bundle them all up together, they're all going to just contribute to each other's copper. I know that's a simplistic way of looking at it, but it's the way I understand it. So, radio VSD is a big problem. We must screen. We must screen, 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 and screen again. 360-degree screening. So we can't do this thing. I see this done a lot. I see that done a lot. I've actually got pictures of that done, where what people do is they pull the outer braiding off, they make a hole in it, pull the inner cores out, and then they take the outer braiding and lug it and attach it to the framework. That's not good enough. That is not good screening, and it will cause faults. Radio VSD will happily transmit out from here. That's not good enough screening. This is okay screening. This is preferred screening. That is what we should definitely do. Basically, metal gland it at both ends. With a VSD, we attach the screen at both ends. The reason we do that is that you can't assume that the entire motor turn box is down to earth. If you've got a motor turn box like this, then you've quite often got a gasket between those, and you can't assume that we've got a good earth bond between the top and the bottom. So if we screen at the top on the motor and we screen at the VSD, then we know that all of it is screened 360 degrees throughout its entire length. So we must screen, 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 and screen again. If you don't use screen cable, you're probably contravening the non-ionization laws. You must screen throughout the entire length from the VSD to the motor. I know of one site where they didn't use screen cables, and then they went through the very expensive exercise of taking their cable and encasing it in metal conduit, retrofitting metal conduit onto the top of cable. And they did this because they were running foundation field bus in this factory, well, mine site, and radio VSD was getting out, and it was shutting the foundation field bus down. And it would be intermittently shutting the foundation field bus down. So, non-screening, the VSD will work, the motor will work. It's everything else that will shut down. Okay, so screen, 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 and screen again. Safety-wise with VSDs, there's large capacitors in there. You don't just hit the isolator, open the cover, and stick your screwdriver in. You're going to kill yourself. You hit the isolator, you walk away for 20 minutes. In that 20 minutes, you get the manual out and you read to check that it's not 30 minutes. You walk away and give it time for those capacitors to discharge. Basically, I'm overcautious. I always treat VSDs as if it's live work. It doesn't do any harm to go and get a rubber mat and an apprentice to watch you. It doesn't do any harm. You never know. Inductances and capacitances can store power. You can get capacitors in all sorts of places. Just the sheer length and size of copper can store power. And bear in mind that sometimes we could have 1200 volt spikes. It could be that you just pulled a bad chance. You switched the thing off when there just happened to be a 12,000 volt spike on there. And it will be stored in the copper in the cables. You don't want to be finding that. Even 1200 volts, even with no amps behind it, it gives you a nasty surprise. You don't want to be getting a nasty surprise when there's a chance you can jump backwards into bus bars. So be careful with VSDs. Treat them like live working. Always give them a chance to discharge, because they've got capacitors in there. And remember, they've got DC in there. Remember how dangerous, DC is much more dangerous than AC. You get hold of AC, it's going to go bang, it's going to give you a shock, and it's going to throw you backwards. You get hold of DC, your hand will clamp down, and you will stay there until you fry. There's a lot of voltage there, and it's DC. Be very careful.